Hiya and welcome to an introduction to similarity. Our first video is going to be on the linear scale factor. Your success criteria for this topic so far would be describe the difference between a congruent and a similar shape, be able to find the scale factor of either an enlargement or a reduction, and lastly be able to apply that scale factor to find missing lengths, and you should be able to do all of these by the end of this video. Okay, first of all we need to know the difference between two definitions. The first being congruent, and when shapes are congruent they are exactly the same, they have the same angles and the same length of sides like these two shown here. The one we are most interested in today though is when shapes are similar, and that means that the corresponding angles, for example these, will all be the same when they get enlarged or reduced, but the lengths of the sides will be in proportion, okay? So therefore this 4 is in proportion to that 2, and this 8 is in proportion to that 4 over there. And that's the difference between the two types.
This will be true for even much more complicated shapes. For example, this one here, every single length on the bigger shape is actually just 2 times the length on the smaller shape. Whereas the angles, if you look 225 and 225, 45 and 45, they remain exactly the same. Okay, so if we look at these two similar rectangles, by our definition on the previous slide, we know that every angle in the smaller rectangle is going to be exactly the same as the corresponding angle in the larger rectangle. And also that any length on the smaller rectangle is going to be in proportion to any length on the larger rectangle. Okay? The first thing we're going to do is calculate the scale factor, and because the unknown thing, the x, is on the bigger rectangle, we're obviously going in this direction, going from small to big. And to get the scale factor, you do the scale factor, and we're getting bigger, so scale factor of enlargement. Okay. To do that, all you're doing is big divided by small. Okay. And we're going to use the two lengths that have the relationship. So we're going to use the 6 and 3 because we know they're in proportion. So big 6 divided by 3, and that gives you 2. So your scale factor of enlargement is 2. So if you want to go from anything on the smaller rectangle, all you're doing is multiplying by 2. Okay, so to get x, we're going to use that 1 because that's its corresponding length. And now we have the scale factor. It's really straightforward. We're just doing 1, the original length, and we're timesing it by 2, the scale factor. So the new length is 2 centimetres, and that's your done. Okay, this now is with similar triangles, and the same thing still applies. Every angle in the little triangle is going to be equal to the corresponding angle in the larger triangle. Okay, and also that the lengths, so 3 here, is going to be in proportion and have a relationship with the larger length, which is 21. Okay, x is what we're going to be looking for. Therefore, we're going in this direction. We're actually going from big to small this time. So to get our scale factor, it's a little bit different. Instead of going a scale factor of enlargement, we're going smaller. So it's a scale factor of reduction. And that just means that it's small divided by big. So it's just the other way around. Okay. So the small one would be 3 and big 21. And we're just using those ones again because we know they have their relationship. And if we simplify this fraction, you're left with 1 over 7. Therefore, 1 over 7 is our scale factor. That means that to go from anything in the big triangle, all we need to do is multiply by 1 over 7. Which is the same as just dividing by 7. Okay, so to get x, again, what we're looking for, we're going to use its corresponding side on the bigger triangle, which is 14. So x we take 14 and times it by the scale factor. 14 times 1 over 7 is 2. So your answer, we don't have any units, so 2 units.
Right, so again we've got another set of similar triangles where all the angles will be the same no matter which triangle. We're looking for two things now. We're looking for x and we're looking for a y. Okay, and these will be the corresponding lengths for them. But also we have this relationship between 6 and 12, and that's the one we're going to use to get our scale factor. The unknowns are in the little triangle, so we're going for a reduction. So you've got a scale factor of reduction. Okay, and when it's a reduction, we're doing the small length that we've got divided by the big length. So the 6 divided by 12, which is the same as a half. Okay, and that's your scale factor done. Now, to get x and y, we're just going to multiply the corresponding sides of those by our scale factor of a half. So to get x, we're doing 5 times a half, which is the same as just dividing it by 2. You get 2.5. And we don't have any units, so I'll just put units. Okay, and then to get y, you're just doing the 13 times a half. Okay, and you get 6.5. And you're done. Okay, so now this is your chance to have a go free on your own. If you want to just pause this video and try get the scale factor for each and the length of the missing side as well for each. Okay, I'll pause it now. Okay, so those are your answers. You can have a look and see how you got on, and you can always find more examples in class. So you can now go and watch the next similarity video on being able to apply scale factors to the area and volume of shapes.